Velocity time graph is the title. Velocity time graph. Velocity time graph. Short form VT graph. Example, a body is moving according to this rule. Just an example, okay? Without example, how can you understand? The time and velocity given. Time 0, velocity 0. When time 1, velocity 2. When time 2, velocity 4. When time 3, velocity 6, etc. So based on this data, we have to draw the velocity time graph. So on x-axis you have to mark time, y-axis you have to mark velocity, and you have to mark the numbers 1, 2, 3, 4, 5, etc. Here also 1, 2, 3, 4, 5, 6, etc. 0, 0 is there. Where is that 0, 0? It is here. 1, 2 is there. 1, 2 is there. Then 2, 4 is there. When time equal to velocity 4. 3, 6 is there. Join them. You may extend a little bit. This is velocity time graph. Okay. This VT graph is the most important graph. Velocity time graph. We can answer several questions. Normally, a graph will be given to you. Based on this graph, you have to find out the displacement or acceleration like that. Okay. So from velocity time graph, you can find out acceleration and displacement. I will explain that. Let me write a title here. Acceleration. Finding acceleration from VT graph. From VT graph. We can find out acceleration as well as displacement from VT graph. I will explain. Let me draw a general graph, VT graph. This is time and this is velocity. Suppose, remember the velocity time graph, it is not necessary that the line is a straight line. The line may be curved line. Depending on the data, the graph may be a curved one. Suppose we have a velocity time graph like this. Suppose the graph is given to us. Suppose I want the acceleration at a given time. Velocity time graphs given, I have to find out what? I want to find out the acceleration at a given time. For example, when time equal to say 3 seconds. Just an example. When time equal to 3 seconds, what is the acceleration? The velocity, okay, you just look at the graph. You can easily find out the velocity when time equal to 3 seconds. Just look at the graph, you will get it. Velocity. But when time equal to 3 seconds, at that instant, what is the acceleration? We can find it. I will tell you. Listen carefully. At a given time, from the graph, I can find out what? I can find out acceleration. For that purpose, draw a tangent. What is that tangent?
Okay, sir.
So, for example, I want to find the acceleration when time equal to say 3 seconds. What you have to do? Just draw a tangent there. Just draw a tangent. The tangent will be making some angle with the horizontal, right? That tangent will be making some angle with the horizontal. Is it correct? Yes. There will be theta. There will be theta. Let me 1 minute. Let me extend it. Let me extend a little bit. Just draw a tangent. The tangent will be making some angle theta with the horizontal axis, isn't it? Just find out the tan theta, you will get that acceleration. So acceleration, let me write here, acceleration is what? Acceleration is tan theta, which is also called slope of tangent. Okay, tan theta is also called, we studied in the last class, Acceleration is slope of tangent. Slope of tangent drawn to the VT graph, which is nothing but tan theta. So my conclusion is this: if VT graph is given, how can we find out the acceleration at a given time? You just draw a tangent. Tangent means a line touching that point. That tangent will be making some angle with the horizontal axis, right? Take tan of that one. Tan theta you studied in maths, right? Tan theta, which is also called slope. That is the acceleration. Okay, clear? I hope you have understood. Next is displacement. From VT graph. From VT graph, you can find out not only acceleration but also displacement. I will explain that. Suppose a VT graph, velocity time graph, is given to us. Suppose the graph, say like this. Let it be like this. 1 minute. Maybe curve, it may be line, that depends. We have a velocity time graph. I want the displacement. Proof is not required. Please listen. Suppose I want the displacement covered by the body between two time intervals t1 and t2. I want to find out the displacement covered by the body from t1 to t2. Clear? A body is moving along a straight line. I am talking about motion along a straight line. Okay, motion along a straight line. The body velocities keep on changing. At different time, the velocity is actually different. My objective is from time equal to t1 to t2, between two time intervals, how much distance traveled by the body. That is my objective. From the graph, I want to find that displacement. I want to find this displacement between the time intervals t1 and t2. How much displacement it covered, I want to find out from the graph. So you just find out the area under the graph. To find the displacement, what you have to do? You just find out the area under this graph. This area represents what? This area represents displacement. I will write here. This area represents displacement from time equal to t1 to time equal to t2. I don't want to write a long sentence for that. So just find out the area. Normally in question this may be a line. Okay, because for a curved one we have no direct formula for finding area. Maybe normally it will be a line. Okay, in questions. So area under VT graph. Remember, area under VT graph represents displacement. Okay, and remember the area. When you find the area, remember this area, sometimes the region may be below x-axis. I will show you. Let me write it as a note. Listen. Let me write one example. Listen carefully. Suppose a body is moving like this. This is T1 and this is T2. What is the displacement? No doubt. Displacement is the area. Displacement is what? It is the area under this graph. And remember, the displacement has sign actually. The displacement has what? Sign. If the body is moved towards right, the displacement is considered as positive. If the body travel from left to right, the corresponding displacement is considered as positive. But if the body go backward, reverse, if the body go towards left, in that case displacement is considered as negative, like -2 meter, -10 meter, like that. So remember, if the area above x-axis, the displacement is actually area, no doubt. Displacement is positive. The displacement has the magnitude area, no doubt. And if the area above x-axis, the displacement sign will be positive. But in some cases, the VT graph may be downward. In some cases, VT graph may be downward, may be going like this. Between T1 to T2, what is the displacement? Again, area between the VT graph and a horizontal axis. Here also, the displacement covered by the body, also area between the horizontal axis and the VT graph, but the sign should be negative. After writing the magnitude, you have to write the sign. In this case, the displacement is nothing but it is area, but the sign should be minus. So displacement has sign: forward motion positive, backward motion negative. So if we get an area above x-axis, the displacement will be positive. If we get an area below x-axis, the displacement will be a negative. Okay, that is a difference. Okay, clear. Listen, the applications of this graph is, we can derive 3 sets of formulas. Application of this position time graph we studied, velocity time graph we have studied. The application is, we can derive 3 important formulas. That derivation is there in our syllabus. It will be asked in your exam. So let me give a title: derivation. I am talking about the application of this VT graph and XT graphs. Okay, we can derive certain formulas. After this, I will explain the numerical problems. Derivation of the kinematic equation. I will discuss, don't worry about this word. I will explain that. Kinematic equation. Moving with a fixed acceleration. 3 sets of formulas we are going to derive. 3 sets of formula we are going to derive using graphical concept. The 3 equations are, I think you studied, and yes, definitely you studied in the lower classes. Have you seen this formulas anywhere? V equal to U plus AT, S equal to UT plus half AT square. Do you remember this set of formula? Manan, do you remember this formula? Yes. Aaron, you studied that. Yes. I'm going to derive these 3 formulas. Graphical method for second and third. Yes, the graphical method is there for, especially for the second one, there is graphical method. Especially for the second one, we have a graphical method. Okay. The first one, the graphical method is not required. They will ask in exam, they will ask, derive the formula. That's all. Okay. The second one, the graphical method is required. First and third, third one is derived from second. Third one is actually derived from second. So the first equation, V equal to U plus AT. Let me explain all important terms first. There is a body moving along a straight line. Motion along a line. Its initial velocity, I will write all the important terms here. Its initial velocity is U. Final velocity is what? V. And its displacement, from the initial and final position, displacement is denoted by s. Or in some books they use x. No problem, either x or s you can use, no problem. The displacement is denoted by s. Displacement is s, and the body is moving with a fixed acceleration a. U is what? Initial velocity. Let me write everything here. Initial velocity. And v is what? Final velocity. Body was initially it was moving with the velocity u. Finally it is moving with the velocity v. During that period it has got a displacement s. Its acceleration is a. I am going to derive the first formula, v equal to u plus at. Proof of the formula v equal to u plus at. Here the graph is not required. It's very simple, right? We have studied that acceleration equal to change in velocity by time. We studied in the first class. Change in velocity divided by time. Understood? In 1 second how much change happens for velocity? Acceleration is nothing but change in velocity by time. Change in velocity means final velocity minus initial velocity. Change in velocity means final velocity minus initial velocity. And the time taken for this travel is, let it be t. Time taken for this displacement is t. So we studied that acceleration equal to change in velocity by time. Change in velocity means final velocity minus initial velocity by time. The time is the time taken for this travel. Okay. So a equal to v minus u divided by t. You can do the cross multiplication. You can do the cross multiplication. V minus u equal to at. Do the multiplication like this. At. The derivation is there in our syllabus. P minus u equal to at, or v equal to, this minus u can be taken to the other side. V equal to u plus at. Studied in the lower classes. This here the derivation is the most important. Okay. V equal to u plus at. So I hope that you understood the derivation. The first one is very simple. V equal to u plus at. The next formula I am going to derive is s equal to ut plus half at square. Remember, in some textbook they use the letter x. Okay. Okay, whichever letter you may use, no problem. S equal to ut plus half at square. The graphical method to be used. Then only you will get the mark. Okay. For this one, only the graphical method to be used. Consider a velocity time graph. Consider a velocity time graph. This is time and this is velocity. Velocity, let me write it in word. Velocity. Suppose I have drawn a velocity time graph, goes like this, a straight line. Why uniformly fixed acceleration, then the velocity time graph will be a line. Why? For a fixed acceleration, velocity time graph should be a line. Why? Why it is not a curved like this? If the velocity time graph is a curved, it cannot have a fixed acceleration. What is the reason? Because the acceleration will be different. If you draw the tangents, you are getting a different tangents at different points. The theta is changing, right? If the VT graph is going like this, a curved graph, it has a different accelerations at different times. Here tan theta is very, very small. Here tan theta is increased, again increased. So velocity is the slope of tangent. We studied. Sorry, acceleration is the slope of tangent. So here the cannot be curved graph. If the graph is curved, at different times we have a different velocity acceleration. We have a different acceleration because tan theta will be different. So it cannot be curved. So only possibility is line. Okay. So for a fixed, you have to memorize that. For a fixed acceleration, Vt graph must be a line. Okay. So the fixed acceleration Vt graph must be a line. Okay. So this is when time equal to 0. Correct. Time equal to 0. This is where the time equal to 0. Let me write it in words. Time equal to 0 here. And when time equal to t, time t, the body has reached this point. When time equal to t. Okay, let me draw the graph. Let me make a small change in the graph. 1 minute. Let me draw. Graph must be line. There is no doubt in that. Okay, graph must be a line. But it is not necessary that it must be starting from origin. When time equal to 0, the body will have a velocity u. Initial velocity. This y-axis represents velocity, right? When time equal to 0, initially, when time equal to 0, the body has a velocity called initial velocity u. When time equal to t, final time, when time equal to t, the body will have the final velocity small letter v. The body will have the final velocity small letter v. I will repeat, don't worry. So the Vt graph is what? This one is the Vt graph. Let me highlight it. Let me highlight it. This is our Vt graph. This line, for a fixed acceleration, Vt graph must be a line. X-axis time, y-axis velocity. When time equal to 0, I told you that when time equal to 0, the body has a initial velocity u. When time equal to 0, the body has the initial velocity u. So look at this graph. When time equal to 0, the body has the initial velocity u. As the time changes, the velocity changes. When time equal to t, the velocity is v. Final velocity when time equal to t. Okay. Now I want the displacement from time equal to 0 to time equal to t. What is the displacement? You just find out this area. I told you that from Vt graph you can find out the displacement by finding out the area. We get positive area because the area above x-axis. So how will you find out this area? There are two ways. One is you can split into two. Draw a horizontal line, area of the rectangle plus area of the triangle. Or there is a simple technique. There is a simple technique that what is the shape of this quadrilateral? Can you see a quadrilateral here? I will highlight it once again. I want to find the area of this quadrilateral. This highlighted one is a quadrilateral, right? This area I want to find out. What is the name on? Remember, I will write here trapezium. This is nothing but it is trapezium. What do you mean by trapezium then? I will explain that. Trapezium means it is a quadrilateral having two parallel sides. It must have two parallel sides. Look here, these two sides are parallel. That's all. A quadrilateral is said to be a trapezium if it has two parallel sides. This quadrilateral has parallel sides. What are they? Look at this vertical side. This vertical side and this vertical sides are parallel, right? So this one is nothing but it is a trapezium. This one and this one are parallel. So it is a trapezium. Area of trapezium. Do you remember that? I will discuss that. Area of the trapezium. you need three things. One is the parallel sides is required. The length of the parallel sides required, and also the distance between the parallel side also needed. Okay, listen. So I hope you have understood. So trapezium means two parallel sides are A and B, and the distance between the parallel side is h. Then area of the trapezium, if you don't remember, please write it somewhere, half into h into a plus b. If you don't remember this formula, write it somewhere. Area of the trapezium, half h into a plus b. Let me explain this. So area, I want to find out area. Area is the displacement. Area in VT graph, area under VT graph is the displacement. Area half into, let me write the formula, half into h into a plus b. Trapezium, okay? Half into h into a plus b, half into h. What is this h? H is the distance between parallel sides. These left side and right side are parallel sides, right? This vertical side and this vertical sides are parallel. So h is the distance between them. So what is this distance? H is t here, right? H is t. Let me write.
Yes, sir.
Let me write here, otherwise you will forget it. H is t actually. So half into t into a plus b. A and b are the parallel sides. So a is u. Look at this diagram. It is clear that a equal to u and b equal to v. See, this height is what? This height is v actually, and this one is u. So half into t into a plus b. A is u and b is v. To derive the third one, v square equal to u square plus 2as. In exam, all the three equations you have to derive. Okay, the question will be like that. Derive the system of derive kinematic equations of a body moving with a fixed acceleration. You have to derive the three sets of formula. This is the last formula, v square equal to u square plus 2as. We don't need any graph proof, okay? Proof of this. We don't need any graph for this. We know the formula v equal to u plus at. We have already studied one formula, v equal to u plus at. Here I want to derive for v square. I want v square. Squaring both sides. Squaring both sides. Just square both sides. What happens? You will get v square equal to right side is a plus b whole square form. Correct? A plus b whole square. A plus b whole square is a square plus 2ab. If you don't understand, you can ask when I interact with you. A square plus 2ab plus b square. Yes. So let me write one more step. A square plus 2ab plus b square. V square equal to u square plus 2uat, correct? 2aut. If you make a small arrangement, no problem at all. 2aut, no mistake. 2aut plus a square t square. V square equal to u square plus u square plus 2as, right? So one a can be taken out. One a can be taken out, or let me do let me make some adjustment. I will tell you. Let me make an adjustment here. A square t square. Look at this term. A square t square. If I write it as 2 times 1 by 2 into a square t square, is there any mistake? can I write a square t square as 2 into 1 by 2 into a square t square? No mistake at all, because 2 and a half will be cancelled. Clear? Here 2 and 1 by 2 will be cancelled. You will get same term, a square t square. So I made a small adjustment here. A square t square is written as 2 into 1 by 2 into a square t square. Does not make any difference, because 2 and a half cancels, no difference.
Sure.
Next step is v square equal to u square plus 2 into now from the two terms, let me take 2 common. Let me take 2a common. Understood? 2a is present here, 2a also present here. Let me take 2a outside. If I take 2a outside, ut is remaining here. If I take what is that, 2a, okay, if I take 2a outside, 2 is lost, a is lost. Half a t square will be remaining. Half a t square will be remaining. It's very simple. 2 is gone, 2 is gone, a is gone. Half a t square will be remaining. So finally v square equal to u square plus 2a into ut plus half a t square is s. We studied that. V square equal to u square plus 2as. Okay, all of you please listen. Let me write one simple question just to make you understand the concept. Okay, in the next class I will discuss more exercise problems. The theory is over, the problems are remaining. Suppose it's a simple question to just understand the basics. Suppose you are given a VT graph. In the chapter laws of motion, this VT graph, everything is there. This formula, kinematic equations, as well as the VT graph, XT graph, everything is there in the other chapters. 0, 2 seconds, 4 seconds. Let it be 10 meter. Sorry, this is VT graph. 10 meter per second. Time, the y-axis is velocity. Let me discuss a simple question. Okay, velocity. My question is the displacement. This is my question of the body from time equal to 0 to time equal to 4 seconds. During this time interval, what is the displacement covered by the body? That is the question. It's a simple question. So tell me, the velocity time graph is given. We can find out the displacement by just finding the area. Understood? Area under velocity time graph, this one. 0 to 4 second, you have to shade it. From 0 second to 4 second, you have to shade it. Area under VT graph. Please don't forget it. This is VT graph. From 0 second to 4 second, you shade the region below the graph. Just shade the region below the VT graph. That area represents what? Displacement covered from time equal to 0 second to time equal to 4 second. Clear? All. So it's a very simple question. It's a very, very simple question. So the area, is it a trapezium? Yes. Displacement is equal to area under VT graph from time equal to 0 to time equal to 4. Time equal to 0 to 4 second, you have to shade it. Area, it is nothing but it is a trapezium. It is a trapezium. Can you identify the two parallel sides? I will show you. This one and this one are the two parallel sides. So it is a trapezium. Trapezium is very, very important for us. Half into h into a plus b. H is the distance between the parallel sides. Let me write everything here. H is the distance between the parallel side. It is 10. It is clear from the diagram. It is 10. H is 10. If you have any doubt, you can ask at the end. H is 10. A and B are the parallel sides. A is the, let it be this A. A, what is this? It is 2 second to 4 second. What is the distance? 2 second. 2, right? This distance is 2. 2 second to 4 second. What is the distance? 2 second. So this distance is 2. B. B is the distance of this one. 0 to 4. 0 to 4. The distance is 4. 10 by 2 will be 5 into 6. 30 meter is the displacement.